Hey folks, here with you today is Gavin Scharig, here to talk to you about Lookback Time, how it works, and all the great stuff that goes along with it. Before I hand it over to my co-host, Kalani Kayser, I want to ask you a quick trivia question. What is the greatest lookback time that any object can have in the universe? The answer at the end of our video. So now Kalani, what exactly is lookback time?
Well, Gavin, look-back time is the amount of time it takes for the photons of light to travel from one object to another. The look-back time of a certain object, whether it be a planet, star, or galaxy, is the difference between the current age of the object and the age of the object when the light left. In the most simplest terms, it is how long it takes for the light to reach us from an astronomical object. We use look-back time instead of distance for faraway objects because the universe is always expanding, therefore distances between the objects are always increasing. Due to the expansion of the universe and because distance is measured by light, distance does not give us precise measurements of where the object is now, but rather where it was when the light we measured was produced. So Gavin, could you explain in more detail why and how look-back time was created?
Well, of course, Kalani. The concept of look-back time was created because distances between stars and galaxies are always changing in the universe. So it's easier to speak about faraway objects in terms of how much time their light takes to reach us. When we observe light, we are observing light that was produced when an object was closer to us because the universe is always expanding. The object moved away from us during the period of time it took for the light to reach us, so the object is always going to be further away from us than the distance that is determined by the observed light. When further away objects produce light, the photons must travel a greater distance, therefore they will take longer to reach the observed location. As a result, this gives us objects have more time to move apart, causing the difference between the current location and the location of when the light was produced to be greater. We needed a better way to explain distances of faraway objects due to the difference between the observed distance of an object and the actual distance of an object. Let's hand it over to Kalani so he can give us an example.
Well, sure. So the distance between the Milky Way and a distant galaxy is going to be greater when we observe the light that was produced by the distant galaxy than the distance between the galaxies when the light was actually produced. As you can see in the space-time diagram, as the time since the light was produced increases, the distance between the two galaxies increase. So the light from the distant galaxy takes longer to reach the Milky Way than it would if they weren't moving apart. As a result, the light that reaches the Milky Way was produced by the distant galaxy 400 million years ago, and the distant galaxy is actually much older and further away when the photons are observed. So Gavin, what is the look-back time of some of the more mainstream astronomical objects?
Well, let's measure the look-back time from Earth. Beginning our journey with the Sun, which is about 8 minutes away when traveling at the speed of light with a distance of 1 astronomical unit, or 92,960,000 miles. Now let's move at 299,792,458 kilometers per second, better known as the speed of light, for a few hours until we reach Pluto, the leper of our solar system, which has been banished by the planets and demoted to a dwarf planet. From Pluto, we can cruise along out of our solar system for a few years until we reach the closest star to our sun, Alpha Centauri. After reaching the closest star, we coast along, again at the speed of light, for about 2.5 million years until we reach the nearest galaxy to the Milky Way, the Andromeda Galaxy. Well, that's pretty neat.
Yeah, that is pretty neat. Before we conclude our video, let's answer the trivia question we asked at the beginning of the video. What is the greatest look-back time an object can have? Well, the furthest look-back time an object can have is about 14 billion years because the age of the universe fundamentally limits the size of our observable universe. We cannot see farther than the point of which light was produced at the very beginning of time, better known as the cosmological horizon. Well, signing out today for my co-host Gavin Scharig and myself, Kalani Kayser, reminding you, stay classy, Boulder.